Depth first search algorithm. Principle and example. Depth first search is an algorithm for traversing or searching a graph or a tree. It explores as far as possible along each branch before backtracking. On this animation, you can see the order in which the graph is traversed. Implementation. Here we have a graph on which we want to use a depth first search. Remember that, unlike trees, graphs may contain cycles, so we may come to the same node again, as is the case here with the node f. And here we have the code. On the left side, we see a Python implementation of the depth first search algorithm. On the right side, the JavaScript implementation of depth first search. So we have two parts. On the upper part, we simply initialize the graph we saw previously by using an adjacency list. We also initialize an empty set called visited. This is where we will add our visited nodes in order to avoid processing a node more than once when using a graph. We use a set because its in operation has an average time complexity of a big O of 1. On the bottom half, we have our depth first search function. It takes in a starting node, the graph, and the visited set, and this version will print the nodes it visits. So the algorithm is fairly simple. First we pick any node. If it's not visited, we mark it as visited and recur on all its adjacent nodes. To help you visualize this, here's how it executes. We start out at A, we add it to the set, and call two recursions. The first one on B, and the second one on C. Since our program executes linearly, our depth first search on B must finish before the search on C begins. So now we're at B, we add it to the set, and then call the search on its nodes. Now we're at D, and D doesn't have any edges, so we can execute the second half of the search on B, which takes us to E. After E, we're in F, and F doesn't have any edges, so we can backtrack all the way to A. And now we can execute the second half of our first recursion, which gets us to C. By the way, this depth first search is called a pre-order traversal because we print the root first, then the left subtree, and finally the right subtree. If we place the print under the for loop, then the algorithm will be called post-order traversal, because we will have the left subtree, the right subtree, and then the root. And there are also other versions. Because all the nodes and vertices are visited, the time complexity for depth first search on a graph is a big O of the vertices plus the edges. Time complexity on a tree is the big O of the vertices. And that's it. Congratulations on learning the depth first search algorithm. Thanks for watching and see you on the next one.